Two and a Half Admins, episode 21. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And it's only been a week. What's going on? Well, we've decided to go weekly. We got close enough to the Patreon goal. So, you're going to have us every week. But we're not going to record every week. We're going to record every 2 weeks. But you don't need to worry about that. Before we get started, you want to plug your webinar again then, Alan?
Yes. So on January 20th at noon Eastern, which is, I think, 5 p.m. UTC, we're hosting a live webinar about OpenZFS. So that'll cover what's new in OpenZFS, how does it impact your existing ZFS installation, how it impacts how you would plan for future ZFS installations, and also how to get access to those new features of OpenZFS 2.0 on operating systems that don't ship with it yet, like FreeBSD 12 or older versions of like Ubuntu and so on. And if you can't make it live, you can sign up and we'll send you the video once it's done.
Okay, cool. Well, there'll be a link in the show notes. Let's talk about ECC RAM then. And this has been doing the rounds because recently Linus Torvalds went on a bit of a rant about it and how it's all Intel's fault that it's not the standard.
Usually when people talk about why you do or don't have ECC available in consumer gear, they blame the price. Linus isn't buying it, and honestly, I think he's got the right of it. The additional cost of ECC is just not that high. I mean, right now, even with it effectively being like a boutique specialty part, you can get ECC RAM for about a 10 to sometimes 20% markup, from what non-ECC RAM costs. If it was actually being produced at scale where like all RAM was just ECC and that's how it was, I don't think the actual manufacturing cost would go up enough to notice.
Yeah.
Torvald's position is that the real reason that we don't have ECC everywhere is because Intel used it as part of their market segmentation efforts to say, hey, if you don't buy our nice expensive Xeon CPU, you businesses will disable all these features. So they made sure that their consumer CPUs do not support ECC and won't work with it. And that keeps small businesses to some degree from using, for example, a Core i7 instead of a Xeon.
So none of the Core line have ever supported ECC then? It's always been the Xeons?
So there's a couple of the really low-end ones that sometimes do. Like when I got my Kaby Lake E3 1275 V6, the motherboard didn't support Kaby Lake yet. It was only Skylake, and I had to flash it. So I had to find one of the only models of the Intel Pentium things that I could buy for $60 that was Skylake, would let me boot the motherboard, flash the BIOS, and then pull it out and put in my expensive machine because my RAM was ECC, and so I needed a CPU that would be able to boot with ECC RAM. So there are a couple. Usually, it's the really low-end ones designed for embedded stuff. Like remember that Seed Odyssey thing that Jim showed us, stuff like that. But I don't think that particular one actually does ECC, but they do make some like it that have ECC. And so sometimes Intel will slip it into the really low end parts as well. But in general, they only offer it on the server grade stuff.
For the last several generations, the answer there is there has been one or two blessed Core i3 models that would work with ECC. No i5s, no i7s. Sometimes you'll get something even lower, like Alan said, there'll be like a Pentium Gold or something like that. But what you can really rely on is there'll be one or two Core i3 models.
But none of the i9s, the real enthusiast ones?
No, absolutely not. Very specifically not i9s or i7s or anything like that. Because again, what Intel's doing here is they're saying, okay, there are some applications that need ECC RAM, like OEM NAS builds, for example, that don't need a lot of compute power, but they really should have the ECC. And the answer for that used to be, the Xeon version of the Atoms, the Avoton. But unfortunately, the Avoton line is no more, and it's no more because those things tended to, catch on fire within a year or two of you having them.
Self-destruct.
Not literally, but they would self-destruct. So now it's just, there'll be a blessed model of i3 where they don't disable the feature. And again, to be, perfectly clear here, we're talking about disabling feature availability. This is not something extra that needs to be built into these CPUs. It's something that Intel is turning off to keep the market segmented.
Yeah. The i9 example is slightly interesting because you might actually be using, overclocking RAM or something with an i9. And the idea of overclocking and ECC are kind of, mutually exclusive.
Oh, no. I beg to differ. Overclocking with ECC is fantastic because instead of having to run memtest x86 for 8 hours to figure out if your build is stable, you just look and see if you've got ECC errors showing up in the logs. And if you do, you dial it back a little bit until you stop having them. Whereas when you don't have ECC, if your system doesn't just completely lock up, then you still have to run hours and hours of repeated memtest runs, making sure that you're not getting spurious memory errors.
Yeah.
What's the worst that can happen if you do get these memory errors then?
Well, it's generally the thing that makes your computer crash, like the blue screen in your OS or just a kernel panic or whatever. All kinds of spurious errors can be caused by a flip bit in memory. Or, the classic other example is some file gets a bit flipped and it doesn't contain the data you thought it did anymore. And if it's certain binary file formats and so on, that means that it just won't load. It'll just be corrupted. Or like if you've ever used a hex editor to flip a bit in a JPEG, your picture loads fine up to the point where you flip the bit and then everything after it's all gone wonky.
Yeah, garbage. Now, to be completely fair, not every bit flip will result in a noticeable effect. Mm-hmm. If the bit flip happens in an area of RAM, for instance, it's being used for file system cache and that cache never gets hit, you'll never know it happened. If that bit flip happens in an area of memory that's holding, the slack space at the end of a file, you won't know that happened. There's frequently dead space in word processing documents, and, you have it. Beyond that, literally anything can happen. If you have a bit flip happen in application code, who knows what will happen? You could have a security issue, you could have a stability issue, you could lock up the whole machine, whatever. Or, like Alan was alluding to, if you flip the wrong bit in data, you can have an impact that's wildly out of proportion with the amount of data that you actually changed.
And then, of course, you've got the security implications of deliberately flipping bits with rowhammer, etc.
Right. You're thinking, select from the, you're logging into Twitter and suddenly admin bit is set to 1 instead of 0.
ECC RAM generally mitigates rowhammer really well. Now, it doesn't do much to protect against RAM bleed, which is the read version of the rowhammer attack, where you flip bits and the pattern of responses and the way you flip the bits, lets you deduce some information about bits in a physically adjacent area of RAM that you don't have access to. ECC doesn't help with that. But rowhammer, where you actually change adjacent areas, now it can't necessarily make it like rowhammer attacks never happened, but either one of two things will happen if you do try a rowhammer attack on an ECC machine. Either it does get mitigated because the ECC RAM corrects the attack before you flip more than one bit, or on a typical ECC system, the whole thing immediately locks up. So rather than rowhammer causing you a security issue, it causes you a downtime issue. Because most systems with ECC RAM are configured so that if you have an uncorrectable error, the whole machine just immediately halts. Which from a security posture is, far preferable to, well, now your attacker has managed to, smash the stack and some code with, root privileges.
Yeah, so you're into denial of service rather than actual compromise.
Right, and depending on your configuration, it can be a non-masking interrupt or it could just cause the machine to reset, therefore invalidating the contents of the RAM and hoping it doesn't keep happening. But yeah, I think the biggest advantage, like Jim was saying, is that you get those machine check warnings on the correctable errors, so you have a log and hey, I've started suddenly seeing these errors. Either that stick of RAM is bad or somebody is rowhammering it or something.
Yeah, so that all makes sense for server applications. But in terms of people's desktop, laptops, phones, and tablets, does it really make sense for that to be ECC?
Absolutely.
Does it really make sense for it not to be? Like, I would argue the other way. It's like, what excuse is there not to have this protection that costs an extra 10 cents in parts?
Yeah.
All we have to do is not turn it off.
Yeah, exactly. And also, to put some perspective on this, the original IBM PC and the vast majority of PC compatibles up until the 1990s, they all had ECC RAM.
What I find a bit strange about this whole thing is that it's Linus Torvalds calling out Intel specifically, given that Intel is a platinum sponsor of the Linux Foundation, and so ultimately one of his paymasters.
Were you under the impression that Linus is an easy man to buy?
No, but there must be some awkward emails and Slack conversations going on over at the Linux Foundation.
I doubt it. Intel's been hated by people bigger than Linus.
Yeah.
Intel's statement was, Intel supports and validates ECC on products where the feature is recommended by the industry. The industry has determined that ECC memory is most important for data integrity with servers and workstations where Intel supports it with their Intel Xeon processors, which is basically them agreeing that they only do it on their server parts.
Yeah, you peasants don't need data integrity. If your crap gets, corrupted, it doesn't matter. You're worthless peons. It's kind of what that boils down to, really.
The AMD situation is slightly interesting. Like with their newer ones, it's like AMD has unofficial ECC support on the Ryzen range, which basically causes the problem of a lot of motherboards end up not bothering to support it. Like I couldn't actually get a motherboard with the features I wanted that happened to support ECC RAM. I was having to buy new RAM anyway because it was faster, but I would have preferred to have ECC than not, but it wasn't an option. So I don't know that it's definitely mostly Intel's fault because of that segmentation, but AMD is not pushing hard enough to fix it, I don't think. Although, they don't care. They don't sell RAM.
They also haven't been in a position to push hard to fix the rest of the industry. I mean, they're still a minority player now. 3 or 4 years ago, it wasn't entirely clear that they would survive. So it seems a little precious to expect them to have, forcibly fixed the industry through their pressure.
They've taken steps in that direction, which is good. I think they could maybe now start pushing a little harder. But, we can also start complaining at the motherboard manufacturers saying, hey, Asus, why can't I buy all of these Ryzen boards with ECC support?
Yeah, I think there's a little bit of both. I think that at this point, AMD is certainly in a position where it would not be unreasonable for them to be like, future chipsets, yeah, ECC, that's part of the spec. It needs to be there. Because again, I don't really see that causes anybody, a huge amount of cost. We live in a capitalist system, and ultimately, capitalist enterprises are kind of the laziest things on earth. If you haven't given them either the carrot or the stick, they're not going to do it. And nobody's really given motherboard manufacturers either, some carrot to reward them for enabling ECC and consumer stuff, or the stick that says, hey, if you want to be able to say that, this is an, XYZ chipset motherboard that, supports these processors, you need to support this feature.
Yeah. And it's got this 4-level chicken and egg problem of the motherboard manufacturers like, well, none of the companies that make gaming RAM make ECC versions, and so the consumers don't want to buy it. Or, if we made a motherboard that required ECC RAM, the gamers wouldn't know where to buy this RAM because
they are such a small part of the freaking market, though. Yeah. I mean, let's not deify the freaking gamers.
Right.
It's not like you're stuck with, DDR3 or something.
Exactly.
I've got DDR4 3600 in both of the machines sitting in the rack next to me, my workstation and my backup server, right below it in the rack. DDR4 3600, that is more than fast enough for the vast majority of folks out there, including an awful lot of the same gamers we're talking about.
It's pretty close to the top you can get. It's what I just built in my brand new machine.
Exactly. That's what I'm saying. Yes, there are faster clock rate RAMs, but it's all overclocking stuff.
Okay, this episode is sponsored by Linode. Go to linode.com/2.5 to get started with $100 free credit. Whether you're working on a personal project or managing enterprise infrastructure, Linode offers simple, affordable, and accessible cloud computing solutions that allow you to take your project to the next level. Simplify your cloud infrastructure with Linode's Linux virtual machines and develop, deploy, and scale your modern applications faster and more easily. Linode has 11 global data centers and provides 24/7 365 human support with no tiers or handoffs regardless of your plan size. In addition to shared and dedicated compute instances, you can use your $100 credit on S3-compatible object storage, manage Kubernetes, and more. Our website is hosted with Linode, and we couldn't be happier with them. So go to linode.com/2.5 and click the Create Free Account button to get started. That's linode.com/2.5. All right, let's talk about an article from over 6 months ago now. This is from July of 2020. Tavis Ormandy, who fancies himself quite the iconoclast, wrote an article called You Don't Need Reproducible Builds, in which he explains quite reasonably why reproducible builds don't have much real-world value, and that it's something that people seem to be kind of obsessed with, when really the benefits aren't worth all the hassle of it, because a reproducible build, of course, is producing a like-for-like binary with the same source code built in two different places, so that you know that the binary that you've got was actually built from that exact source code. And it's a pretty tricky problem to solve, right? With different build environments, different operating systems, sometimes even timestamps can give you a different hash on the binary you produce.
Timestamps are usually the biggest problem. For a long time, the FreeBSD builds included the host name of the machine it was built on because that was useful. But for the release builds, it doesn't anymore because we try to get towards this idea of a reproducible build. A lot of that effort was less about people being able to confirm that the binary we ship on our website is the same one that was built from the source code, as we wanted to make sure it was possible years from now for somebody to be able to reproduce the same release if they needed it for something. But yeah, from a securities perspective, I can see how this is, if you're going to go that far, then just don't ever bother using a binary.
Yeah, I don't know about all this. I think Tavis really kind of jumped the shark here. I think he's focusing on the wrong aspects of this from a security perspective. Reproducible builds are important because without reproducible builds, you don't know that you can troubleshoot an issue that you're having in a particular binary by looking at a particular piece of source code. The reproducible build is what really ties the binary to the source so that you can say, when I'm looking for a problem in this source, I know that it should be there from this binary. He goes through a real long drawn out scenario of saying, oh, well, there's no point in a reproducible build because in order to reproduce it, you have to build your own binary and then you might as well just use your own binary that you trust. But I think the fact that that, not only your one trusted vendor built that, but that it's widely expected and other people likely are verifying at some point that, yes, this truly is what you get when you compile that source. That's what gives you the assurance that, yes, when I look at this source, I'm looking at the right thing.
But isn't this the point of signed repos and stuff and trusting a company? Say you use Ubuntu, you're putting your trust in Canonical and you're trusting that they have properly signed their repo and things are being hash checked when you're downloading your upgrades or whatever. And you know that what you're getting is what they say it is, because otherwise, why are you running an operating system from a company like Canonical, for example?
You're arguing for proprietary code, Joe. Why do you need open source? Just trust your vendor and it'll be fine.
But at the same time, well, how does one person at Canonical check that the release built by somebody else actually was that before they sign it? You end up needing something like this anyway, just so that the people that are going to sign it can verify that the binary is actually what they expect it is. Even just if it's, we happen to build it on this computer that had some extra cruft on it that ended up impacting what the final binary was. Or like, you remember, must be 8 or more years ago when kernel.org got hacked. And then they found that they stood the machine back up after reformatting it and it rooted itself, even though it hadn't been connected to the internet yet. And they found that they had persistent malware in the BIOS. It's like, how do you make sure that doesn't happen without using multiple machines and doing something like reproducible builds to make sure you actually got what you got?
So what we're talking about here is the ability to set up a quorum, where if you do the same build on 3 separate machines, you should get the same answer on all 3. And if you don't, there's a problem. And that allows you, even if you are talking about, the one organization and the one vendor, that allows that vendor to have multiple build farms that are doing these same builds and should be coming up with the same answers, but none of them trust each other or can talk to each other. And it is a significant additional barrier to entry to have to compromise all 3 build farms instead of just one. I mean, there's a lot of security considerations here that it kind of blows my mind that Tavis is just jumping right by as though they don't matter.
What about the point that different distros build things differently? So you might get, Nginx or whatever, a version of that from 2 different distros, and they're going to have their own spin on it somehow. They're going to use different build flags and stuff on purpose.
You don't expect those to match. You just expect it to match that's the whole reproducible build thing. To reproduce the build, you have to be able to reproduce the original environment. And of course, if one machine is on CentOS and another one's, on OpenSUSE, that's not the same environment. You're not going to get the same build. Nobody's expecting those 2 builds to come out the same.
I think the main things are, it's about controlling what gets into that environment. So that means erasing all the environment variables from whatever machine you're running on and only doing the ones that we're specifically setting to control this build, and doing things like specifically setting the date for all of these builds to be the planned day of the release or whatever, and controlling a bunch of these variables so that you will get the same binary, but also documenting that so that at some later point, someone else can do the same inputs and should get the same output.
Exactly. And also, it means that you're kind of freezing this environment. If you're making a change to the environment, it's a very deliberate one, and it keeps you from having problems going from one build to the next where, the same code built fine in the last version and you made a change to the code and then you had a bug in your next build, but it turns out the bug wasn't in the actual code that you changed. It was in the change in the environment that you weren't tracking because you're playing it all loosey-goosey. When you're doing reproducible builds, you're going to be paying a lot more attention to the environment and making sure you have a clean environment. And that's one less source of error to creep in, because now if in the exact same controlled environment, you build the old version, you don't have a bug. You build a new version, you do, okay, this new code caused this bug. You frequently assume that in an uncontrolled build with an uncontrolled environment, but it may not be correct. It's very possible that, you changed a flag, you changed an environment variable, something was different between those two, and you didn't notice it, you didn't pay attention. Reproducible builds eliminate that.
One of the other advantages you get is if you can reproduce that environment, it means Delta updates are much easier to build and end up being much smaller. Back before FreeBSD had reproducible builds to the degree it does now, FreeBSD Update did some pretty interesting gymnastics to build Delta binaries, where it would do a build, then do a build again with a different timestamp, and then do it a third time with an even different timestamp to be able to figure out which changes in the binary are just a timestamp and just ignore those. And then only the other changes would actually go into the Delta update that shipped to people. So it would purposely change the host name and the date and so on, and be like, if it changed in all three of these, where the source code was the same, we know that was basically a problem with our reproducibility, and we'll exclude that bit from the binary diff.
Good old BFMI, brute force and massive ignorance.
This has some other interesting impacts. A friend of mine, Paul Doedek, who ported ZFS to FreeBSD back in the day, his company makes security appliances. And they've come up with this idea of the Zero Trust Initiative, of a way to allow vendors to have access to the source code and be able to do a reproducible build, but not open source. Basically, if you're buying our appliance, you can make sure that you can audit the code for backdoors and bugs and bug doors and so on, and check that the binaries you're running match the source code that we're giving you, but we're giving it to you under a license that says, you don't get to keep this or whatever. It's not open source. You can't go and do things with it, but you can make sure that the SSL intercept appliance you just bought is actually not worsening your security.
So in conclusion, then, Tavis is wrong.
I think so. It feels a little odd, honestly, to be calling out Tavis Ormandy, of all people, as wrong on a security issue, because he's a highly respected security researcher. And I think rightfully so. But yeah, I also think he got this one pretty badly wrong.
He's got his little Q&A on it. And I don't think any of his points are invalid. In particular, I can see how that, reproducible builds in the idea that, all right, I'm going to take the source code and I'm going to build this trusted binary and compare it to the official one, and then be like, okay, it's the same, so I can keep using the official one. Well, if you're going through all the trouble, you might as well just use the one you built, is true. But like Tim was saying, not every person needs to do it that way. And it's kind of like we were talking about, the idea of having this quorum where if a bunch of people have checked, then if you trust them, you don't have to do the checking yourself. But even outside of all the security context, it's very useful to be able to have this. And maybe even in the proprietary case, if you have that and a license that says, if a company goes out of business, you can still build the binary for this software you licensed or whatever, could be very useful. On top of the idea that, sometimes you're going to want to build FreeBSD from 4 years ago and be able to produce the same thing that the original had, because you need that for some reason.
Okay, this episode is sponsored by Datadog, the performance monitoring and analytics solution for real-time visibility into a Linux environment. Combining metrics, traces, and logs in one unified platform allows you to get a bird's-eye view of your entire infrastructure. You can also see any underutilized cloud or on-premises servers via the real-time auto-generated host map. Datadog's machine learning-based alerts eliminate false positives and make sure that you only receive alerts on issues that matter. You can automatically detect unanticipated outliers, anomalies, and errors with Watchdog, the auto-detection engine that surfaces performance problems in your applications without any manual setup or configuration. Start your Datadog trial today by visiting datadog.com/25admins. Start your free trial, create one dashboard, and you'll get a free Datadog t-shirt. That's datadog.com/25admins. Let's do some free consulting then. If you want to send in your questions for Jim and Alan, you can do so via email show@2.5admins.com. And if you want to support creation of these episodes, go to 2.5admins.com/support, and you can either support us via PayPal or Patreon. And for $5 or more on Patreon, you can get an advert-free RSS feed. Okay, Tom writes in, I recall Jim mentioning he gets used equipment off eBay. Any pointers on buying used equipment? Some basics to keep me from buying bricks. I'm looking to replace or expand my Plex of desktop and USB drives with something sporting direct SATA drives.
So I actually don't tend to use eBay. I avoid it like the plague, to be honest. For just general purpose, looking for refurbished equipment, Newegg and Amazon are both very good sources. It's really easy to find refurbs of, whatever spec of server or desktop or laptop you're looking for, really. And the important thing there is just always look at the vendor who is selling it on Newegg or Amazon. Make sure that their customer complaint percentages aren't too high. I reserve eBay as more of like it's a last choice. I mean, it's certainly not that you can't buy good hardware on eBay. You can, but it's just a little bit more of a freewheeling, shady kind of a marketplace, in my opinion. You definitely need to be more careful about who you're buying from. The barrier to entry is a lot lower. You may be buying things that, claim to be refurbished from people who are not in any way a hardware vendor and are just trying to, unload their used crap. So you got to be more careful.
Yeah. eBay, I would say generally stick to things that have a store that not just some random guy's account, but a store that's, sold 5,000 or 10,000 things or something. One site I really like is unixsurplus.com. They have lots of Supermicro and Dell gear. They have an eBay store, and that's how I originally found them when they used to be called Mr. Rackables. But they have their own website. You can buy direct from them if you prefer. They often will accept a best offer bid on eBay lower than the price they list on the web store. So that's why I bought it through eBay a couple of times. Plus, you get the PayPal buyer protection stuff, but that's, you hope you don't need that anyway. So yeah, Unix Surplus has good stuff. They have machines where they've kitted them out specifically to be like a FreeNAS setup for Plex, so that you make sure that you get the right kind of HBA and they've already flashed it for you and so on to take some of the headache out of it. So that can be nice. Other used ones, I mostly focus on much more established eBay accounts. I've got really good deals on $15 dual port 10 gigabit NICs and so on from the right kind of refurbisher or computer recycling place. And, definitely look for a place that actually has a good reputation. Like Jim said, you want a low complaint rate and a reasonable return policy.
Yeah, and I'll also say on eBay, be very wary of auctionitis, for lack of a better word. When you've got somebody that's selling things, for auction and doesn't have a buy it now listed, or, has a ridiculous buy it now listed, you can get really invested in this idea that you're going to get a thing cheap and somebody's going to snipe it out from under you later. It's real easy to go wrong with all that crap when there's no fixed price. You also see a lot of people that are listing items for prices that look too good to be true. But it turns out if you don't actually really intimately know what those items are and what they're worth, you don't realize that this really incredible price for this thing is, actually, like 150% markup over what you could buy it for retail somewhere more reputable. That happens a lot.
Yeah. And, they definitely had a whole spam of things like people selling PlayStation 4s for really high prices or people selling them for really low prices. And it turned out you were buying a picture of a PlayStation.
Or buying the box, like the pasteboard box it came in.
Although I found a legit auction the other day. It was clear what it was for, but it was for the empty cardboard box from the old vintage 80s box from the Cocoa Pebbles cereal. It's the original box from the 80s. Why do you still have this and why are you selling it for $24?
All right, well, we'd better get out of here then. Remember, show@2.5admins.com if you want to send in your questions for Jim and Alan. You can find me on Twitter @Joe Ressington.
I'm on Twitter @JRSSNet.
And I'm @Alan Jude.
We'll be back next week.